Thanks for tuning in at Brackeys.
Hello everyone and welcome to video number 5 on making a multiplayer FPS in Unity. In this video we take a look at adding some really cool spring physics to our movement, and also we're going to add a camera rotation limit, which a lot of you has been requesting and which is definitely something you need to do before release. And finally we're going to add some thrusters to our players so that we can actually fly. So we're going to script all of this. It's going to be a lot of coding and some physics stuff, and it's going to be a lot of fun. So let's go ahead and get started. So let's start by adding these cool spring physics to our player. In order to do this, let's just hit play and go under LAN host in order to get our player in the game. Now in the scene view, let's select our player and have a look at his components. We need to add a new component, and you can see I've already searched for joint in here. But if we go under physics and scroll down, you can see the configurable joint, which is the one that we are going to be using. The effect that we want kind of resembles the spring joint effect, but we need to tweak a few things that are only configurable in, well, the configurable joint. So let's click that, and you can see just why it is called what it is. I mean, we can pretty much change anything from in here and create any kind of joint effect. So therefore it also looks very frightening, but don't worry, we're only going to use a few of the settings and I'll explain everything along the way. So the tab that we kind of want to look under here is the Y drive tab. And in here we can set a mode, and we want to set this to position. And that means that our ball will now try and reach a certain position. And the position that it tries to reach is what it's spawned at up here. So you can see our cube was at position 1 when it was spawned, a Y position of 1. And therefore this becomes kind of the anchor point, the point that this object will apply forces in order to reach. So therefore the point of the spawn position suddenly becomes very important. And this is something that we are going to need to change later in order for our ball to be able to land on other objects and have that as kind of the position that it wants to reach, so that it doesn't stand on a cube and applies a lot of force in order to get down to the ground plane. Well, we want that to become the new ground plane, but that's something that we're going to add in the future. For now, we are just going to have him float at the 1 point. So if we now that we know that that's the position that we're going to strive for, well, then we would think that if we drag this up, he's just going to bump down there. But he stays the same. And the reason why, we need to bump up this position spring amount. And this is the amount of force that we want to apply to our spring. So if we set this to something like 20, you can see that now we get this spring effect. However, at the moment, it's a very loose spring, and it's very bouncy. And the bounciness is definitely something we want, but we want to limit this a bit. Then you would think that we would use the position damper, but this has absolutely no effect. So we leave that at 0. Instead, we go up and take a look at our rigid body settings. Under here we have a property called drag. Drag is different from mass, because if we increase the drag, we are going to slow down quicker, but it doesn't actually make our object heavier. I like to think of drag as air resistance. So how much resistance do we meet, and therefore how quickly do we slow down after force has been applied. So if I change this to something like 10, you can see just how effective this will be. We slow down very quickly, and this takes away all bounciness, and that's way too high. Instead, I found something like 4 to be a fairly reasonable amount. You can see we still get that bounce, but it's no way near as crazy. So I think that kind of resembles this thruster force that we want to be applied under our object. You will also notice now that when I do this, we don't collide with the ground. And the reason why is fairly simple. There's no real collider on the ground at the moment. So we are going to add that. So let's just copy our... Actually, let's add that in a second, because we have one last thing that we want to set under our configurable joint. And that's the maximum force. Because right now if I drag this cube up really high, you can see just how much force is applied. This is not very realistic with gravity, as gravity is a constant force of negative 9.81. And therefore, we need to set a maximum force so that it doesn't act like a spring, but instead acts like gravity is pulling it down. Therefore, we set this to something like, I don't know, 30 or 40. And this is not the same as gravity. We don't set it to negative 9.81 or 82. But still, trust me, this is normally a pretty good number. So now you can see when I drag this up, it's much more reasonable speed it's falling down with. So that becomes much more realistic, and now it looks like a constant force. So now that we have these settings, what we want to do is we want to copy this component, exit play mode, and remember we've been in play mode this entire time. Go down here, click here and hit paste component as new. So now we've added it to the prefab and it's going to spawn with these settings. You can see under Y drive, these positions are set. In a moment we're going to set these through a script. But firstly I want to go to the environment and add a box collider to a ground plane. So let's just enter box collider there, and that's pretty much all we need to do. Now when we hit play, select LAN host and go in here to mess with our player. There he is. We can see that if we drag him up far enough and let go, he's simply going to collide with the ground there. Cool. So now that we have these proper physics working, I think it's time to add some kind of flying mechanic. So in order to do this, we're going to edit our player motor and player controller script. So first off, let's look at the player motor. So let's double click that and open it up in Visual Studio. And we're going to open up the player controller too. So I'm just going to double click that. So actually, let's start with the player controller now that it's already open. So you can see in here we have a few variables. We have the speed and the look sensitivity. Well, of course, we want to create a new one for the thruster speed. So let's also make this a serialized field in order to be able to keep it private and still view it in the inspector. And we'll call this thruster force. And we'll default that to a fairly high number, and that's going to be 1000. Now in the start method, I actually want to do something, but let's just stay away from that for now, and let's just implement the thruster force, and then I'll talk about how we can make sure that the spring ignores, or that the player ignores the spring when we are using a thruster, because when we have the both applied at the same time, it's hard to get cool results. But we'll talk about that in a second. So let's just have a look at applying this thruster force. So down here we can say that we want to apply the thruster force, and if we look at our movement script, we can kind of see where we're going. So we have this velocity variable that we put into a move method down here, and that basically takes care of everything. Well, we can do something similar here. So we can say that if we get an input dot get button, so if the button jump is pressed, and this is again one of those inputs defined in the Unity editor, well, then we want to kind of set our thruster force variable on the player motor to the thruster force variable defined in here. So let's start out by making a vector3, and we are gonna call this underscore thruster force. So this is going to be our local thruster force, and we want to default that to vector3.0. So unless we get this jump button, we are going to apply a force of 0, 0, 0, meaning that we are not going to do a thing. If we then get that button, well, then we want to set underscore thruster force equal to vector3.up. That's going to be a vector of 0, 1, 0. And then multiply that with our thruster force as defined above. So that's kind of the logic that we need here. And then we want to call something on the motor that will apply this force for us. So I'm just going to move this down, apply the thruster force down here. And we simply want to say motor dot apply thruster. And in here, we want to set or we want to input our underscore thruster force. So again, this is going to be 0, 0, 0 if we don't get any input. And if we do, it's going to be 0, thruster force, 0. Cool. So here we calculate the thruster force based on player input. Awesome. So let's save that and let's head into the player motor. And in here, we want to go up here and create a new private variable that will store our thruster force, vector3, and we'll just call this thruster force again, and then it's going to default to vector3.0, because unless we get any input, we want it to have a 0, 0, 0 value. And then down here, we use some kind of setter, so public void, and let's just call this thruster force, and it's going to take in a vector, or what we call this apply thruster is what we call this. So apply thruster, and it's going to take in a vector3 thruster force, and remember the underscore there. And it's simply going to set our thruster force variable equal to the value passed in, so underscore thruster force there, just as we've done with anything else. And this is going to get a force vector for our thrusters. Cool. And now under our perform movement, I think it's fine if we do our thruster force in here, since it is actually movement. We're simply going to check, just like we do with velocity, if thruster force is not equal to vector3.0, because we can save ourselves the move position call if we don't need to do anything at all. And of course, this is not going to be move position. This is going to be add force. And we do this because we actually want this to behave as a force, not just a rigid movement. We want this to calculate or to slowly speed up and all that. So add force, and it's going to take in a vector3 force, and this is of course going to be our thruster force. And we want to multiply with that with time.fixed delta time, just as we do up here. And then in order for this to stay constant, no matter our mass, because I want us to be able to change the mass of our player without having to tweak this value all the time, well, then we can set force mode equal to force mode.acceleration. So we can simply put that in as a second argument. And you can see if I just hover over this, it says adds a continuous acceleration to the rigid body, ignoring its mass. So that's simply all we have to do in order to make mass or take mass out of this calculation. So now it's actually going to perform this calculation for us, and it should apply it to the rigid body. And you can see now we have this thruster variable. So if we were to go and hit play, LAN host, we can actually apply some thruster force. However, you will notice that the spring quickly forces us down. And a solution to this would be going under the configurable joint and setting the maximum force to something smaller than the force that we are applying. And therefore, this would have to be really small, maximum force of 5 maybe. We are almost there, of 2. And you can see we can go further now, but it's still forcing us down. So instead, what we're going to do, and we're going to set this back to 40. What we're going to do is we're going to disable the configurable joint while we are using our thrusters. But as you can see, the configurable joint can't just be disabled. And there are many reasons for this, not something I'm going to go into, but I'm going to show you how we can work around this. Well, basically we want to control our position spring so it equals 0 while we have our thrusters applied, and while we are not using them, well, then we want to go back to the amount that we've set. And in order to do this, let's actually strain away from setting anything in the configurable joint and then have some variables inside of the controller instead, or our motor. No, let's have them inside of our controller that will configure the joint. So instead of setting all of the values down here, let's simply require that component and then set all of the stuff in here. I think that works way smoother, especially if other people want to use the same script or we want to use it on other objects. Well, we don't have to set any custom settings. We simply add the script that adds the configurable joint component and sets it up. Alright, so let's integrate this configurable joint into our script. So let's open up the player controller script here. Let's just expand that. And up here, let's make a reference to it first of all. And if we make a reference, well, then we want to require it also, because we're not going to do any kind of component checking. So require component type of, and then configurable joint. And we want to add the reference down here. So that's going to be a private configurable joint. And we're just going to call this joint. And in the start method, we simply want to set joint equal to get component of type configurable joint. Awesome. And now down here, all we need to do is... Right, okay, so I just had to think there for a moment. Well, basically we want to set up this configurable joint with some different options. And the first thing we have to do is, well, make these options available in the inspector. So under the thruster force here, I want to create a new section. And in order to organize this properly in the inspector, we can create a header for this. So in here, we'll simply type joint options. Or something like, you could also do spring settings, whatever you want to do. We'll just do spring settings now, and a colon. And that will just make, if we save this and hit into Unity and wait for this to update, we actually have to have some variables below, it looks like. So let's just make some. We have a serialized field, and this is going to be a private, and this is going to be a joint mode, joint drive mode there, and we just want this to be called the mode. We also want another serialized field, and this is going to be a private float, and this is going to be our joint spring, and let's actually call this joint mode, and a third serialized field, because we don't want to change our dampening effect, because dampening amount, because that has no effect. So this is going to be our joint max force, and we are going to default that to, let's say, 40, and the joint spring to 20. Cool, so now when we save that and hit into Unity, we should be able to see this in the inspector, and you can see the header there, the spring settings, and then we have these different settings here. And the joint mode, we want to set that to precision, and we can also maybe set that to a default value. So we'll say joint drive mode dot precision is going to be the default value there. Cool. So now we have the different settings, but then we want to apply them to our joint component. And let's do this through a function. So let's make a private method down here, because we only want to access it from within our controller. And we are simply going to call this set joint settings. And in here, because the joint settings is a struct, which we haven't talked much about, we need to use a certain syntax, and the syntax looks like this. So we access our joint, and then we go to the Y drive, because that is the drive settings that we want to control. So under configurable joint, you can see the Y drive here, and that is the settings that we've made. So the Y drive is a struct called a new joint drive. So the joint drive struct contains information about the mode, the spring effect, the max force and all that, and we want to input that there. You can't actually access these individually. You cannot set position spring like this. If we try and do that, you can see that it throws an error here because of the way that this is programmed. So we actually have to make this a new joint drive, and then we can fill that with information. So normally here we would put an open and close parenthesis. Well, now we use these curly brackets, and in here we can then set, first off we can set mode equal to joint mode, comma, and then we can set position spring equal to joint spring, and we can finally set maximum force equal to joint max force. There we go. And I don't want this on one line, so we're just gonna make some room here to kind of organize the code a little bit. There we go. That looks much cleaner, and maybe actually also move this down there. And that looks really nice. And private void, this is going to be, we don't want to return anything. And we want to actually be able to input a parameter here, because the thing that we are going to be changing dynamically is the joint spring. So let's create a float here, and let's do underscore joint spring, and let's set that into there. So instead of just using the value up here, we're going to use the value passed in. And now up in the start method, all we need to do is we want to say set joint settings, and we want to input our joint spring. So just the default amount that we've set in the inspector. Then down here, when we are applying thruster force, so if we get this button jump and we're applying the force, well then we want to set joint settings, and then we want to set a spring amount of 0. We don't want the spring to affect anything at all. And if we are not getting this button down, well then we want to set some joint settings, and we want them to set the joint spring to the joint spring passed in. Okay, so if that makes sense to you, great. If not, please just copy my settings here and pick up on what makes sense. I mean, the reason this might seem a bit clunky, but that's because it's programmed as a struct and there are so many settings, so setting them individually can be kind of clumsy. But once we have this set up here, it's just going to work fine, and I don't think we're going to have any need to change it. Awesome. So now that we have that in place, we should be able to go into Unity, check if all of this is still working. It looks like it, and now hit play and select LAN host. And now if we go into, if we try and use our thrusters here, you can see that they actually completely ignore the joint there. So, and we can continue as far above as we want to. But we want to also set our drag here. So I forgot about that before. So we want to set that to 4. And we can also adjust the thruster force and maybe the spring amount. 20 is maybe a bit too much. So let's try 15 instead. And let's jump in here and we can see what that looks like. And that looks a lot better, I think. So we get this much more smooth effect. And I think we actually want to set our thruster force to something like 1200. That feels a lot better. But again, this is something you can play around with just as you want to. So I'm going to set that back up to 20 and maybe try 1300 here now. Oops. 1300. Hit play. LAN host. And yeah, this feels much more snappy and cool. So that's basically all for the spring effect. So the last thing that we're going to be doing here is clamping the camera rotation so that we cannot look at what is behind us. So right now, if we go in here and look down, you can see we have an issue here. We just want that to stop at something like negative 85 degrees, and the same if we look upwards. We can do the same there. We want to clamp that too. So in order to do this, let's open Visual Studio. And let's look at the player motor, because we want to do this where we are actually performing the rotation here. So first up, let's create a variable. And I actually want to change how we are doing the camera rotation just a bit. So first off, let's just create a serialized field here. And that's going to be a private float. And this is going to be the camera rotation limit. And we're going to default that to 85 F, because we want that to be a float. And we want to apply that. But at the moment, we are using this camera rotation, which is basically our input multiplied with our look sensitivity. And we're using cam.transform.rotate to apply this rotation to our current rotation. But I want to kind of do this manually instead, so we have control over how the rotation is applied, and therefore we can clamp the rotation correctly. So if we just scroll up here and change this from a vector 3 to a float, that will allow us to use this as an X rotation only. And we are just going to default that to 0. And we want to change this down here too. And we're changing this to a float because that's going to make it a lot easier for us to apply the rotation when not having to think about all of the other axes. So you will see what I mean in a second. So we want to change that to an X, that to an X, that to an X. And down here we want to completely replace our rotation code. So new rotational calculation. And then in our player controller, we want to change this a bit to account for this change. So instead of making a vector 3 called camera rotation here, we're going to make a float called camera rotation. And you can do an X there, which we're going to do, I think. And instead of making a vector 3 here, we simply do underscore X rotation multiplied with look sensitivity. And that's basically all we have to change in here. So back in the player motor now, we can take a look at actually setting this. So basically we want to kind of track our current rotation on the X-axis. And in order to do this, we want to make a new private variable up here. And that's also going to be a float. And that's going to store our current camera rotation on the X. And that's going to also default to 0. And then down here under the perform rotation, we want to set let me just think about this. We want to say that our current camera rotation plus equals our camera rotation on the X. So whatever rotational value we get, we want to add that onto our current rotation. And I've done this before, so I know that this is going to be a minus equals, but this will basically inverse the rotation. So if you get a weirdness in basically the camera being inverted, well then you just need to change this from a plus to a minus, or a minus to a plus. So that's what you adjust there. And then we basically want to set current camera rotation X equal to math.clamp, and we want to clamp the current camera rotation X between a minimum and a maximum value, and that's going to be our minimum camera rotation limit, comma, camera rotation limit there. So a negative camera rotation limit, comma, the positive camera rotation limit. So in our case, negative 85 degrees to 85 degrees. And then we simply want to apply this to our transform. So we simply say cam.transform.local Euler angles equals a new vector 3. And this is where it becomes really easy that we've only actually taken into account the rotation on the x-axis, because our camera itself is a child of the player, and therefore it's also always going to have a rotation of whatever x amount, and then comma 0, comma 0. And therefore we can simply put in here our current camera rotation, comma 0, comma 0. And we don't need to do any advanced calculations with quaternions or anything like that. We can simply input it into the local Euler angles after doing the clamp, and that will do the trick. So if we just want to kind of comment this out, well, we set our rotation and clamp it. And then we apply our rotation to the transform of our camera. So if we save this now and collapse that and look at our player, we should see the camera motor has a camera rotation limit, and we now press play, land host, and you can see that there's a limit when we look down and there's a limit when we look up. So that's basically all we have to do. We can now fly. We have this spring bounciness effect. We have working physics now because we've added the rigid body, and I'm just going to end this video with showing you that. And we have this rotational clamp. So just for fun, let me actually play the game again here. Let me go into the scene and spawn a 3D cube. Let me just move this up right above the player. And let me add a rigid body to this cube, and let me show you how cool it is when these interact. So add a rigid body, and you can see that the physics here are working perfectly. So that was basically it for this video. I hope you enjoyed it, and I'll see you in the next one.